Hello guys, welcome to the Triune Physics aka Physics Bible. Today I'm here to help you and to give you some ideas and concepts on how to answer JAMB questions. And this will help you to score at least 99 in your physics exams. Now, I'm going to be using the triune concept. Every question you read, if it has mathematical problem, try to extract 3 things. Always check your questions. You see that at least 3 things will be given to you, or 2, and the third will be unknown. Okay? So, in this channel, we term that to be the triune concept or the triune method. This method is to help you to be able to simplify examination questions and to answer them appropriately. If you are able to extract your data, then your problem is half solved, because at least you have idea of the said topic. So if you observe, you see that 3 things are in operation when you consider dimensional system or dimensional formula. For example, MLT, mass, length, and time. Then if you are picking length, you see that length can be regrouped into, we have the height, the length, and the breadth. Or you can say the width. You can see 3 in 1, right? Alright, let's pick time. For time, we have the past, the present, and the future. Can you say 3 in 1? Then for mass, which is matter, you can see solid, liquid, and gas, 3 in 1. So if you observe your formulas, physics formulas, you see that they are in 3 in 1, agreeing in 1. Look at your mathematical formulas too. So please, when solving physics questions or problems, always try to extract the triune components or the given data. Okay? If you're able to extract the given parameters or given data, you will be able to think of the formula that will be able to solve that particular problem. So also try to connect them to the triune components. After extracting the data, connect them to the triune component, then source for the formula or equation that can connect these triune components together. Are we here? So if you are able to adhere to this principle, I'm telling you, you'll be able to attempt all mathematical problems in physics, and then you make the unknown parameter the subject of formula. That is it. So this tutorial video has been tailored to help you cover the syllabus of JAMB for this year. And I'm telling you, we have touched virtually all the topics. If you are able to master the system and the concept, you'll be able to score high in this year's JAMB examination. So these questions are from the most important topics. Please go through them, learn them, and get yourself equipped for this year's JAMB exams. So we're going to be solving the first 30. I've extracted 30 most important physics questions out of 40. These 30 questions are all calculations. Are you here? Are you ready to go? So let's dive right in. Question 1. A carpenter working at a construction site mistakenly drops his hammer from a height of 125 meters. How long does it take to reach the ground? This question is under motion. Are you here? Expect questions on motion. Now, but the procedures are all the same. So the triune method on how to solve this, you are going to extract the triune data, the 3 parameters given. So let's observe them from this question. Now, the height is given to be 125 meters. That is h is equal to 125 meters. Okay? Then how long does it take to reach the ground? What is that? That is time. In a triune component, that is time. Okay? So our T is unknown. That is what it means. I hope you are following this. Then how long does it take to reach the ground? So to reach the ground, it means our initial velocity is 0. Are you here? So if that is the case, you can see that this question has to do with height. It has to do with gravity. Okay? So because it drops from the height. I hope you are following this. So our G is 10 meters per second squared. Okay? 10 meters per second squared. So which formula do you think can be used to solve this problem? So I'm going to be using S, which is the same thing as H. Okay? But we use H is equal to UT plus 1 over 2 GT squared. That is the second equation of motion. Okay, this is carved out from the second equation of motion. So if we are using this by substitution, our H is 125. So 125 is equal to 0 times T plus 1 over 2 times 10 times T squared. Okay, so that we have 125 is equal to 0 plus 1 over 2 times 10 times T squared. Are you here? So it gives you 10 over 2t squared. So that 125 is equal to 5 times t squared. So we're going to divide through by 5. So that if we divide through by 5, 5 will cancel out 5. Then t squared is equal to 125 over 5. And 125 over 5 will give you 25. So square both sides now. If you square both sides, t is equal to the square root of 25 and is equal to 5 seconds. That is it. Question 2. Question 2. If an object just begins to slide on a surface inclined at 30 degrees to the horizontal, the coefficient of friction is given to be. So the triune components from this question, the object begins to slide on a surface inclined at an angle 30 degrees. So you see that this has to do with right angle triangle right here. So if we are going to depict that, then we're going to draw a diagram. So how do you solve questions of this magnitude? You see that the triune component here is the sine, the cos, and the tan. And with this, it will give you hypotenuse, it will give you adjacent, and it's going to give you opposite. I hope you are following. So with this, the angle is given to us. Theta is 30 degrees. Okay? So we are bringing in SOHCAHTOA now as our triune system or component. Then we can now say that sine theta is SOH and CA, then it gives us TOA. Now let's compare this. Let's compare this. You see that your O is here, your A is here. So H cancels out H. So sine theta over cos theta will give you tan theta. Are you here? So tan 30 will give you what? Will give us 1 over root 3. Are you following? So most of the time, JAMB questions will come in short form because you don't have calculator, of course. Yes. Question 3 now. Let's go. Question 3. A load of 5 Newton gives an extension of 0.56 centimeters in a wire which obeys Hooke's law. What is the extension caused by a load of 20 Newton? These are our options. Okay. So solution. Our given triune components or datas from this question, we're going to extract them now. If you want to solve your question and to get it correctly, please always extract your datas. Is that clear? So let's begin. The load is given to be 5 Newton, and that is force. Our force is 5 Newton. That's the number 1. The number 2, you have extension of 0.56 centimeters. Are we together? So our E is given to us to be 0.56 centimeters. Remember, this is in centimeters. So let's proceed further. What again is given to us? Our K is unknown because what is the extension caused by a load of 20 Newton? So our F is equal to KE. Are we here? We're going to solve this question twice in twofold. So we are picking the first. because K is equal to F over E. So that by substitution, 5 Newton over 0.56 centimeters will give you what? 8.93 Newton per centimeters. Now you've gotten your K. So we can now solve for the second part of the equation. What is the extension? So now our triune components again, so that we can find the answer to our equation. Our K is now 8.93 Newton per centimeters. Are you here? Then what again is given? What is the extension? So our E is unknown. Is that clear? Then load of 20 Newton. So our F is equal to 20 Newton. So with this, we'll make E the subject of the formula from F is equal to KE. So E is equal to F over K. So that 20 over 8.93 Newton per centimeters will give us, if Newton cancels out Newton, then we are left with centimeters. Are you here? We give us 2.24 centimeters. Are you here? 2.24 centimeters is our answer. Now, I'm going to give you a hint. Always check the options, the SI unit written alongside the options before you begin to solve. The SI unit will give you a clue, and it will also guide you if you are going to do any conversion during your solvings, so that you don't finish solving before you convert. I hope you are following. So during the process of solving your problem, you can now begin to convert even before you get to the final answer. That would save you some time. Question 4. A brass rod is 2 meters long at a certain temperature. What is the length for a temperature rise of 100 Kelvin if the expansivity of brass is 18 times 10 raised to minus 6 per Kelvin? So our triune data as given from this question, you see that our L1 is equal to 2 meters. Are you here? Of course, then our temperature rise, which is the delta theta, is equal to 100 Kelvin. Are we together? Then if the expansivity, so alpha now alpha is given to be 18 times 10 raised to minus 6 per Kelvin. Are we together? So that is our alpha. Always try to extract your data correctly, okay? It will give you an idea on how to source for your formula and how you can solve your problem. So using alpha is equal to L2 minus L1 all divided by L1 delta theta. This, by substitution, will give us what? Our alpha is given to us, okay? And they're asking us for what is the length. So our L2 is unknown. Are we together? So you see that our triune component from these questions are length, okay, followed by temperature, followed by our constant, which is alpha, linear expansivity. So substituting, we have 18 times 10 raised to minus 6 is equal to L2 minus 2 all divided by 2 into 100. So by cross multiplication, we have L2 minus 2 is equal to 18 times 10 raised to minus 6 times 2 times 100. So L2 minus 2 is equal to 18 times 10 raised to minus 6 times 2 times 100, which will give you 200 exactly. Then we're going to make L2 the subject of the formula. So that L2 is equal to 18 times 10 raised to minus 6 times 200 plus 2. So that our L2 will now equal 2 plus 36 times 10 raised to 4. Exactly. So that our final answer becomes 2.0036 meters. That is the answer to this question. So always understand the concept of the triune component and to help you to solve your problems perfectly. So let's proceed to the next question. Question 5. A boy drags a bag of rice along a smooth horizontal floor with a force of 2 Newton applied at an angle 60 degrees to the floor. The work done after a distance of 3 meters is, so these are our options. So solution, the given data, given triune parameters from this question include number one, the force. The force is 2 Newton. So F is equal to 2 Newton. Then applying at an angle. The angle is theta. So theta is equal to 60 degrees. Are you here? Then the work done after a distance of 3 meters. So our distance is given to be 3 meters. So what is the work done? W is equal to unknown. Are you here? So if you're able to extract your data in this format, I'm telling you, you'll have an idea on how to solve these particular equations. So using work done, which is W is equal to work done and is equal to force multiplied by distance. But our component of force has an angle, so F cos theta multiplied by the distance. Are you here? So that W is equal to 2 multiplied by cos 60 multiplied by 3. So that W is equal to 2 multiplied by cos 60 is 0.5 times 3. So that your final answer becomes 1 multiplied by 3. So that our W is equal to 3 joules. Are you here? That is good. So if you settle down, I'm telling you, 99 is a perfect score for you. Is that clear? Don't forget to subscribe to our channel and share these videos with your colleagues or classmates for more tutorials on mathematics and physics problems. Now, let's proceed with question number 6. Question 6 is on resistors, electricity. Are you here? So this is the circuit diagram roughly drawn. So let's look at the question. These are our resistors: 1 ohm, 2 ohm, 2 ohm, 2 ohm, 3 ohms, and then we have 1 ohm resistor. The question is the total resistance measured at PQ in the diagram above is. These are our options. So solution, you're going to follow the best method using the triune method. Now, for you to be able to solve this question perfectly, you should be able to know if the resistors are connected either in series, that's number one, triune component, or parallel, which is number 2, or series parallel combinations. Are we together? So, but for this, the first 3 I circled are in series. So pick them and solve them sequentially. So our R for these 3 resistors are R1 plus R2 plus R3. So R1 is equal to 2 plus 2 plus 2. Then our RT for these 3 will give us 6 ohms. So with these, we're going to redraw this circuit, okay, and fit in or fix our 6 ohm resistor into the original circuit. Let's redraw the diagram. If we do that, what are we having? This becomes our new circuit, okay? Then recall that our datas, let's recopy the datas. We have 1 ohm, 3 ohm, then our 6 ohm becomes 1 resistor now. Can you see the connection now? So, but 6 and 3 ohm resistors are in parallel. Can you see it now? So we pick them bit by bit or part by part so that you will be able to understand. Now, how would you be able to differentiate between series and parallel connection? For parallel connections, the resistors will split into 2 from a junction or node. But for series resistors, there is no junction. They are connected end to end. Okay? Please take note of this. Now, the formula I'm about to use for these parallel connections is only for 2 resistors that are connected in parallel. Only 2. If there are more than 2, don't use this. Okay? So R is equal to R1, R2 divided by R1 plus R2. By substitution, you have 3 times 6 divided by 3 plus 6, so that you have 18 over 9, and your final answer becomes 2 ohms. Are you here? So we're going to pick this 2 ohm resistor and fix it into the circuit again. So we're going to redraw this circuit again, okay, so that will fit in our 2 ohm resistors. So if we redraw this circuit, our new circuit will now become this: 1 ohm, 1 ohm, 2 ohm. Can you see that all of them are connected in series? Because they are connected end to end. So RT now is equal to R1 plus R2 plus R3, because we are now having 3 resistors. So that we have 1 plus 1 plus 2, 2 plus 2 is equal to 4 ohms. This gives us our final answer. Option C is the correct answer. So let's proceed to the next question. I hope you are following us. If you are not, pause the video, replay it for better understanding. Question 7 now. It reads, an electric cell with nominal voltage E has a resistance of 3 ohms connected across it. If the voltage falls to 0.6 E, the internal resistance of the cell is? So solution: the given triune data from this question using the triune method, you see that the nominal voltage E is given. Okay? If the nominal voltage E is equal to E, then E is equal to what? Because the question says an electric cell with a nominal voltage E has a resistance of the 3 ohms. So even though E is not given directly, but it is given, we can find it, substitute for it, and solve for it. So E is equal to the sum of terminal PD, which is uppercase V, and the lost volt, which is a lowercase v. Okay? If we are going to rewrite this, we are going to have E is equal to V plus V. So it has a resistance of 3 ohms connected across it. So this will help you to know that this is uppercase R, external resistance, external load, 3 ohms. Okay? Then, if the voltage falls to 0.6 E, meaning our terminal PD, which is V, is equal to 0.6 E. Are you here? Then, internal resistance of the cell is, so we're now looking for the small r is unknown. Anytime you hear of internal resistance, that is small r in ohms. So recall by combination that E is equal to V plus V. The V here is the uppercase and the V here is lowercase v. Are we here? By expansion, all are in volts, the SI unit. So all of them are in volts. So for you to obtain the nominal voltage, simply add the terminal PD plus the lost volt. So let's draw the diagram to this question. If this is our diagram, you see that our external resistance is given to be 3 ohms. Okay, so recall that our E, okay, is equal to E. Then our V is equal to IR, and our V is also IR. Okay, but differences is in the resistance, the load, external load, and the internal resistance. So if we substitute into this original equation, then E is equal to V plus V, right? So E is equal to IR plus IR. Here, what is common here? E is equal to I into R plus R. I've given you this so that in case your question comes in this form or format, you'll be able to solve your problem. But let's solve this problem now properly. But our terminal PD, which is V, is equal to IR, right? You can see that there. So by substitution, our PD is V and is equal to 0.6 E is equal to IR. Are you here? So what again is given to us? 0.6 E is equal to 3 I. Remember that our resistance is given to be 3. So let's name this as equation 1. So 0.6 E is equal to 3I. So let's do the same thing to the internal resistance. Okay? So from E is equal to V plus V, the lost volt or voltage, which is lowercase v, is equal to E minus V. By substitution, V is equal to 1 minus 0.6 E. Okay? Let's assume that E is equal to 1, so that V is equal to 0.4 E. Are we together? So therefore, we can say that IR is equal to 0.4 E. Let's label this as equation 2, equation 2. So we have this as equation 2. Let's solve further now. From equation 1, okay, 0.6 E is equal to 3I. So let's make I the subject of the formula. So divide through by 3. Okay? So that 3 divides 3. So I is equal to 0.6 E over 3. Are you here? This is equation 3. So anywhere we see I, we're going to substitute that. So from equation 2, let's do the same thing. IR is equal to 0.4 E. So divide through by R, so that R cancels R. Then I is equal to 0.4 E over R. Remember, we are looking for small r, right? So this is equation 4. So we're going to equate these two I together, so that I is equal to I. So I of R, uppercase R, is equal to I of lowercase r. Okay? So 3 and 4, so let's write it properly now. IR is equal to IR. Okay? So 0.6 E over 3 is equal to 0.4 E over R. Cross multiply, so that you have 0.6 E multiplied by R is equal to 3 into 0.4 E. So that you divide through by what? 0.6 E. 0.6 E. So that 0.6 E cancels out each other. R is equal to 3 times 0.4 E over 0.6 E. So that R is equal to, if you cancel out this, what are you going to have? 3 times 0.4 divided by 0.6 will give you 1.2 over 0.6 and is equal to 2 ohms. That becomes our final answer to this question. Don't forget that under this topic, you must not forget your EMF, your terminal PD, and the lost voltage. The combination of these three will give you the answer to any question that comes under this topic. Please subscribe to our channel if you haven't done that. Now let's proceed with question 8. An electric iron is rated at 1000 watt, 250 volt. The corresponding maximum resistance and accompanying current is, so this question is 2 in 1. Okay, we have to calculate for resistance and also calculate for current. So solution, the given data from this question include, number 1, we have the power. Okay, the power is 1000 watt. And then our voltage is also given to be 250 volt. So the corresponding maximum resistance, our R is unknown and our I is unknown. Are you here? So if we are going to solve this, you must also be able to connect these data with your formulas for power. So if we are doing that, then we know that using P is equal to IV, we also know that I is equal to P over V. So that 1000 divided by 250 will give you 4 ampere. So this gives you your current. Then P is equal to I squared R. So that you now have R is equal to P over I squared. So that 1000 divided by 4 squared will give you 1000 divided by 16. And R is equal to 2.5 ohms. This gives you your final answer to this question. So always remember your formula for power under electricity. Now let's proceed to the next question. Question 9. It goes, a tugboat is traveling from Asaba to Onitsha across the river Niger with a resultant velocity of 20 knots. If the river flows at 12 knots, the direction of motion of the boat relative to the direction of water flow is given to be. So this question you can see that is under vectors. So if we are going to solve this question using this diagram, you see that hypotenuse is given, okay, and adjacent is also given. So the given data from here, you see that our R is 20 knots, which is our hypotenuse, okay. Then our 12 knots is the adjacent. So applying SOHCAHTOA into this, or Pythagoras theorem, you will understand that this question will be solved very easily. So when you have question in this format, please try to connect it to trigonometry so that you will be able to solve your question properly and very sharply. So SOHCAHTOA now, if you observe our data, which of these can we use? You will see that we can use cos theta. So if we're applying that, then we now have that cos theta is equal to adjacent over hypotenuse. So if we are doing that, cos theta is equal to our adjacent over hypotenuse will give us what? 12 over 20. So that cos theta is equal to 0.6. Theta is equal to cos inverse of 0.6. So the cos inverse of 0.6, theta will give us our final answer to be 53.13 degrees. I hope you have seen the answer to that question. So question 10 now. Question 10 goes, two bodies X and Y are projected on the same horizontal plane with same initial speed but angles 30 degrees and 60 degrees respectively to the horizontal. So the question is asking us, neglecting a resistance, the ratio of the range of X to that of Y is given to be unknown. So the given triune data or the triune components from this question, if we are going to extract the given data, let's begin now. Let's pick them out one after the other. We have two bodies, body X and body Y, right? So we're going to extract the data for body X, we extract the data for body Y. So our U is U, okay, for both body X and Y. Is that clear? We're going to use that to replace that or substitute for that. Then our theta is equal to 30 degrees and 60 degrees respectively. Is that clear? Then the next data given to us, we are to neglect resistance. So the ratio of the range of X to the range of Y is unknown. Okay? So we'll now pick our formula for range under projectile. So that we have the range of X is equal to U square sine 2 times 30 divided by G is equal to U square sine 60 divided by G. Let's do the same for the range of Y. So the range of Y is equal to U square sine 2 multiplied by what? 60 divided by G is equal to U square sine 120 over G. Are you here? So I'm going to divide the R of X over R of Y. Okay? So let's substitute so that you have U sine 60 over G divided by U sine 120 over G. So if you invert this, okay, if you invert this, your division sign will change to multiplication so that U squared sine 60 divided by G multiplied by G all over U squared sine 120. Okay? G will cancel out G, right? And U will cancel out U. So that sine 60 over sine 120 is equal to 0.866 divided by 0.866 is equal to 1. So the ratio of X to Y is equal to 1 over 1. So 1:1 is our answer. Is that clear? Let's proceed now to the next question. The next question is under equilibrium of forces. A 90 centimeter uniform lever has a load of 30 Newton suspended at 15 centimeter mark from one of its ends. If the fulcrum is at the center of gravity, the question is, what is the force that must be applied at its other end to keep it in horizontal equilibrium? So let's assume that this is the diagram, okay? If we do that, you now see that our data are being displayed as seen in the diagram. So our center of gravity is at 45 centimeters. So taking the moment of force about the fulcrum, okay, which is the equilibrium position, okay, you will now have force times distance is equal to force times distance. The sum of anti-clockwise moment is equal to the sum of clockwise moment. Are we here? So that 30, which is the force multiplied by distance, so that our distance for anti-clockwise moment is 45 divided by 100 minus 15 divided by 100 is equal to the force multiplied by the distance 90 divided by 100 minus 45 divided by 100. So that 30 into or multiplied by 0.45 minus 0.15 is equal to F into 0.90 minus 0.45. So that 30 times 0.30 is equal to F times 0.45. So 9 is equal to 0.45 F. Divide through by 0.45 so that our F is equal to 20 Newton. Next question. Question 12. A force F is required to keep 5 kilogram mass moving around a circle of radius 3.5 meters at the speed of 7 meters per second. What is the speed of the force? Or what is the speed if the force is tripled? Okay? So given triune data, number 1, we have the mass, 5 kilogram. Number 2, the speed is given to be 7 meters per second. Okay? Number 3, the radius is given, r is equal to 3.5 meters. Okay? Then, recall what is the speed if the force is tripled. So we're going to have these data in two form or in twofold. So our F is unknown. Is that clear for the first part? So the force in action is called the centripetal force. Are we together? So let's solve for the first part so that our F is equal to mv squared divided by r. So that 5 multiplied by 7 squared divided by 3.5 is equal to 5 times 49 divided by 3.5. So that we have 70 Newton. Okay? So we're going to pick the second part now. If the force is tripled, that's what the question said. If the force is tripled, so the F is equal to 3F and is equal to 3 multiplied by 70 and is equal to 210 Newton. So master your data, master your parameters, and these data will help you in solving for your problem. So what is the speed if the force is tripled? We've not calculated for speed yet. We're going to do that now. So to find speed, which is velocity, okay? So F is equal to 210 Newton. Our mass is the same, 5 kilogram. Our radius is the same, 3.5 meters. Then our V is unknown. So F is equal to mv squared divided by r. By substitution, our F is 210 is equal to 5 multiplied by V squared over 3.5. Cross multiplying. So that I have 5V squared is equal to 210 times 3.5. Divide through by 5 so that V squared is equal to 210 times 3.5 divided by 5. So that V squared is equal to 147. So take the square root of both sides so that V is equal to the square root of 147. And our answer is 12.1 meters per second. So this gives you a final answer. I hope you are here. So let's proceed further with the next question. The next question is on waves. A particle moves in a circular orbit of radius 0.02 meters. If the speed of the particle is 0.88 meters per second, calculate the frequency in circles per second. Are you here? So given triune data from this question, our radius is given to be 0.02 meters. Okay? Then what again is given to us? If you observe our speed is 0.88 meters per second. Are we together? Then calculate the frequency in cycles per second. So our F is unknown. Are we here? So let's begin to solve this question now. Recall from your circular motion, okay? And from your waves, recall that V is equal to omega R. Are you here? Omega is equal to 2 pi F. Is that clear? We're going to use these two formulas. Hence, for V is equal to omega R, so if we make omega the subject of the formula, we're going to have omega is equal to V over R. So that by substitution, 0.88 divided by 0.02 will give you 44 rads per second. Is that clear? So omega is equal to 2 pi F. So F is equal to omega over 2 pi, and is equal to 44 divided by 2 pi. And this will give you 7.00 per seconds. So that gives us our frequency to this question. Please, if you have questions, you can drop them in the comment section down below. Question 14. A block and tackle system is used to lift a load of 20 Newton through a vertical height of 10 meters. If the efficiency of the system is 40%, how much work is done against friction? So solution, the given triune data, our L is equal to 20 Newton, which is our force. Our height, which is the distance, is given to be the distance moved by load is given to be what? 10 meters. Are we together? So if the efficiency of the system is 40%, efficiency is 40%, okay? How much work is done against friction? So the work done against friction is unknown. So we need to find our work done before we can solve for work done against friction. Are you here? So work output is equal to load times the distance moved by load, okay? Because we know that work is equal to force times distance. So 20 times 10 is equal to 200 Newton. So efficiency is equal to work output all over work input multiplied by 100. What are we looking for from here? So that our load times distance moved by load, okay, divided by work input multiplied by 100 is equal to efficiency. Is that clear? Remember, we are solving for work input. So work input is equal to, if you cross multiply, load times distance divided by efficiency multiplied by 100. By substitution, 20 times 10 multiplied by 100 all divided by our efficiency is given to be 40. So that we have 200,000 divided by 40. So our work input is equal to 500 Newton. Is that clear? So now we want to solve for the work output. Okay? Or let's say the work output is equal to work input minus the frictional force. Is that clear? So if that's the case, we are solving for frictional forces. Then we make that the subject of the formula, okay? Making F of R the subject of formula. Then F of R is equal to work input minus work output. Let's rewrite it. Work input is greater here. So work input minus work output We want to avoid negative sign. Exactly. Work output. So that F of R is equal to 500 minus 200 is equal to 300 Newton. That gives you your final answer. Next question. The lower fixed point and upper fixed point of a resistance thermometer are 0.5 ohms and 3.5 ohms respectively. If it records 2.5 ohms in a certain environment, what is the temperature of the medium in Kelvin? Solution. This question is under temperature measurement. So lower fixed point, you must understand that. The upper fixed point, you must know that. The measured point or the unknown point must be noted. Check our channel. We have taught this topic properly and vividly. Check our tutorials videos for that, please. Now, if you look at the question, you see that the triune component for the first part, which is the resistance thermometer, we have 0.5 ohms, we have 3.5 ohms, and then we have 2.5 ohms as the given data for lower, upper, and measured points. Then we are to convert to Kelvin, absolute Kelvin. So this is the resistance thermometer, exactly, or you call it the resistance scale. So now for Kelvin scale or thermometer, our lower fixed point will be written, okay, lower fixed point. We have our upper fixed point, the second triune component, and the measured point or unknown point, the third triune component, unknown. Then upper fixed point is 373. Yes, lower fixed point 273 Kelvin. Is that clear? So we have our data complete. So we're going to equate the two formulas together. So what is the original formula? How do you construct or derive your equation or formula? You will know that your measured point minus your lower fixed point, all divided by upper fixed point minus your lower fixed point. If you understand this, you form or derive your formula. So measured minus lower divided by upper minus lower. That is it. So I'm going to equate this for both resistance and absolute Kelvin scale. Are we together? So our measured is 2.5 minus 0.5 all divided by 3.5 minus 0.5 is equal to theta. Let's represent this with theta. Theta minus 273 all divided by 373 minus 273. So we cross multiply from this so that we have 2 over 3 is equal to theta minus 273 over 100. Cross multiply so that we have 2 times 100 is equal to 3 into theta minus 273. So 200 is equal to 3 theta minus 819. Collect like terms, 3 theta is equal to 200 plus 819. And this will give us 1019. So divide through by 3 so that 1019 divided by 3 will give us 339.67 Kelvin. This gives us our final answer to this question. Let's proceed further. A metal of mass 0.5 kg is heated to 100 degrees Celsius and then transferred to a well-lagged calorimeter of heat capacity 80 joules per Kelvin, containing water of heat capacity 420 joules per Kelvin at 15 degrees Celsius. If the final steady temperature of the mixture is 25 degrees Celsius, find the specific heat capacity of the metal. So, solution, recall that heat gained or heat energy gained or lost is equal to heat capacity multiplied by the temperature change. Are we together? So, our Q is equal to C delta theta okay, by interpretation. So if you understand this, you now know that our triune component of this question, for us to be able to solve our answer, we have metal, we have calorimeter, we have water. These three. So the heat lost by the metal is the first, okay, and is equal to heat gained by the calorimeter and the water. Is that clear? So by combination, it will give you the total energy. So Q is equal to C delta theta and is equal to C times 100 minus 25. Okay, that is for the metal. Are we together? You can see that here. 100 minus 25. 25 is the steady temperature, equilibrium temperature. Okay, so heat gained by water. Okay, let's use calorimeter is equal to Q of C and is equal to C delta theta. So Q of C is equal to, our C is 80 times 25 minus 15. I hope you're getting it. 25. So let's proceed further. So that for water now, okay, heat gained by water, we're going to use Q of W is equal to C delta theta and is equal to 4,200. Okay, given from the equation is 420, exactly 420 into 25 minus 15. So we have gotten our three datas. So Q is equal to QC plus QW. Are we here? So that if we begin to substitute now, what do we have? We now have the first. C multiplied by 75 is equal to 80 multiplied by, okay, 80 multiplied by 10. Is that clear? Plus 420 multiplied by 10. Okay, so that 75C is equal to 800 plus 4200. 75C is equal to 5000 divided through by 75. Our C is equal to 5000 divided by 75 will give you 66.67 joules per Kelvin. This gives us our answer for this. So heat capacity, which is C, is equal to the mass multiplied by our specific heat capacity. So mass of metal, which is M, is equal to 0.5 kilogram. Is that clear? Then what again? Our specific heat capacity of metal, which is lowercase c, is equal to uppercase C divided by M. So that we have 66.66 divided by 66.67 divided by 0.5. Okay, so that we don't have space here. Let's rewrite this. So that we have 133. Let's rewrite it here. 133.33 joules per kilogram per Kelvin. Okay, this gives us our final answer. Next question. Before starting a journey, the tire pressure of a car was 3 times 10 raised by 5 Newton per meter squared at 27 degrees Celsius. At the end of the journey, the pressure rose to 4 times 10 raised by 5 Newton per meter squared. Calculate the temperature of the tire after the journey, assuming the volume is constant. So, our given data from this, the initial pressure as given from the equation, P1 is 3 times 10 raised by 5 Newton per meter squared. Then, at 27 degrees Celsius, okay, so that gives us our T1, okay, is equal to 27 degrees Celsius. And we need to convert to absolute Kelvin, please. So 27 plus 273 will give you 300 Kelvin. Okay, you do the same thing for the final pressure and temperature. So the pressure rose, so final temperature or pressure rather, P2 is equal to 4 times 10 raised by 5 Newton per meter squared. Then let's write that now. Final pressure, P2 is equal to 4 times 10 raised to power 5 Newton per meter squared. Our T2 is unknown. So from P1 over T1 is equal to P2 over T2, then T2 is equal to P2 T1 over P1. Okay? So by substitution, T2 is equal to 4 times 10 raised by 5 times 300 divided by 3 times 10 raised by 5 to give you 400 Kelvin, or 400 minus 273 degrees Celsius, which will give you 127 degrees Celsius. That gives us our answer. Next question. A wave of frequency 10 Hz form a stationary wave pattern in a medium where the velocity is 20 centimeters per second. The distance between adjacent node is, so from this wave equation, the given triune parameters, the frequency is 10 Hz, then followed by what? The velocity, 20 centimeters per second. Okay? The distance, which is wavelength, is unknown. Is that clear? It's unknown. So with this, from V is equal to F lambda, okay? Lambda is equal to V over F and is equal to 20 over 10 and is equal to 2 meters. So distance between adjacent node will give us what? Lambda over 2. That is 2 over 2 and is equal to 1. So 1 centimeters is our answer. Is that clear? The next question, question 19. The diagram below illustrates a variation of the displacement y of a wave particle with time t. If the velocity of wave is 250 meters per second, calculate the distance between two successive particles in phase. So this is the diagram. So solution, our triune parameters as given, the velocity is 250 meters per second. Then calculate the distance between two successive particles in phase. We need to know our wavelength. That is one cycle. Okay? So our t for one cycle is equal to 0.02 seconds. Are you getting it? For only one complete oscillation or revolution. Okay? For one wavelength. So if we are doing that, then take note of our A. Okay? From the point of origin to our A place. So frequency now, which is F, is number of oscillation over time taken for the oscillation. So you now have 1 over 0.02 is equal to 50 Hertz. That gives us our frequency. So V is equal to F lambda. Lambda is equal to V over F. So 250 divided by 50 will give you 5.0 meters. Okay? That gives us our answer. Next question. Two mirrors of the same length are arranged as shown in the diagram above. A ray of light NO strikes the system at O and emerges along PQ. The emergent ray has been deviated through how many degrees? Right here. So if you are having a diagram of this sort, use your knowledge of angles, okay, to solve this problem. Angle 90, 180, and the rest. Is that clear? So if this is 40 degrees, then we have 40 degrees. Because angles, the sum of angles in a triangle is 180, okay? If this is 50, this should be 50 degrees. This is 50 degrees, okay? So that this gives us 40 degrees. This is also 40 degrees, right? Then we have our D1, we have our D2. Is that clear? So the question is asking us for the emergent ray, the angle that has been deviated. So D1 plus D2 will give us our D. Alright, let's write that for better understanding. Our D is equal to D1 plus D2. So recall that D is equal to 180 minus 2I, or D is equal to 180 minus 2R. Are we together? So if we are bringing this into consideration, then we can now say that our angle between N and O, NO is 50 degrees, okay? Considering the normal and the incident ray. So D1 is equal to 180 minus 2I. So 180 minus 2 times 50 will give you 180 minus 100. So that we have 80 degrees as our D1. So we'll do the same thing for D2 now. Exactly. Considering our normal PQ, if we say that the ray of light is P and Q, okay, then our angle is 40 degrees. Exactly. So that D2 is equal to 180 minus 2I is equal to 180 minus 2 multiplied by 40. So that 180 minus 80. So that our D2 will give us 100 degrees. So remember that D is equal to D1 plus D2. Exactly. So let's do that now. So that our D is equal to D1 plus D2. So that we have 80 plus 100. Our final answer becomes 180 degrees. I hope you are following. So if you have questions, drop them. If you have not subscribed, subscribe to this channel for more tutorials. Which of the following expressions gives linear magnification produced by a concave mirror of radius of curvature r if u and v are the object and image distance respectively? So solution: the given triune components or data or parameters from this question, we have number 1, our radius of curvature, which is r, is given to be r. Okay? Then if u and v are the object, remember that focal length f is equal to 1 over 2r, okay, which becomes r over 2. Let's write it as r over 2. Is that clear? Then we are given the linear magnification to be v over u. Remember that magnification is v over u. So using 1 over f is equal to 1 over u plus 1 over v, mirror equation. Let's substitute now. By substitution, we now have 1 over r over 2 is equal to 1 over u plus 1 over v. 1 over r over 2 will give you 2 over r. So 2 over r is equal to 1 over u plus 1 over v. Is that clear? So what are we going to do from here? Multiply through, or both sides, by v. Is that clear? We're going to multiply through by v. So 2v over r is equal to v over u plus v over v. So that 2v over r is equal to v over u plus 1. So recall that v over u is equal to m. So by substitution, m is equal to v over u and is equal to 2v over r minus 1. This gives us our final answer. I hope this was clear to you. Let's proceed further now with the next question. Question 22. Calculate the refractive index of the material for a glass prism in the diagram below. Look at the options. So let's look at the diagram. This is a triangular prism. Is that clear? So look at the angle of prism is given to us from this question or from the diagram to be 60 degrees, the triune components or datas, 60 degrees. Then the angle of deviation is 30 degrees. So refractive or refracting angle of prism, A is equal to 60 degrees. Then number 2, angle of deviation, D is equal to 30 degrees. Then number 3, a refractive index is unknown. Is that clear? So which equation would help us in this question? So using refractive index is equal to sine 1 over 2 into A plus D, all divided by sine 1 over 2 into A. Then N is equal to sine 1 over 2 into 60 plus 30, all divided by sine 1 over 2 into 60. So that sine 1 over 2 into 90 over sine 30. Okay? So sine 1 over 2, 90 will give us sine 45. So N is equal to sine 45 divided by sine 30. Our options are in short form. Always look at your options before you solve any problem. So from trigonometry, sine 45 is 1 over root 2 and sine 30 is equal to 1 over 2. So by substitution, so N, which is sine 45 over sine 30, is equal to 1 over root 2 divided by 1 over 2. So that our refractive index will give us 1 over root 2 times 2 over 1. If we invert, so that 2 over root 2 is your answer. But we are not done. Multiplying both the numerator and the denominator by root 2. We're going to have our refractive index to be 2 over root 2 times root 2 over root 2. So that we're going to have 2 multiplied by root 2 divided by root 4. So 2 root 2 over 2. Is that clear? So 2 will cancel out 2. Our refractive index is equal to root 2. I hope this was clear. Please always check your options before you solve any physics questions so that it will be easier for you to know what you're going to do before obtaining your answer. Not after solving everything. You check your options and you see that they are in short form. And you didn't use short form. It will give you another headache. So please settle down, check your options, read your questions, extract your data, solve your problems. Is that clear? Let's proceed. A man stands 1/3 of the way between two walls and clap his hands. He hears two distinct echoes, 1 second apart. If the speed of sound is 330 meters per second, the distance between the walls is... So solution, let's assume that this is the distance between the walls. Okay? Then the man is standing in between, exactly as X altogether. Then if that is the case, our wavelength is what we are looking for. Okay? If this is our wall, okay, if this is our wall and this is also our wall, then we can say that 1/3 of X is equal to X over 3. Okay? Now, if we are solving this further, this will give us X minus X over 3 and is equal to 2X over 3. I hope you are following this. So from V is equal to 2X over T, we are dealing with echo. Okay? Then T is equal to 2X over V. Is that clear? So let T1 equals X and is equal to X over 3. Let T2 equal X and is equal to 2X over 3. Is that clear? So substitute now. So that T is equal to 2V. T is equal to 2X over V rather. So that T1 is equal to 2 times X over 3 divided by our V is 330. Our T2 is equal to 2 times 2X over 3 divided by 330. So T2 will equal 2 times 2X over 3 or divided by 330. So the time interval between the echo will become T2 minus T1. Are you here? Look at it. T2 minus T1 and is equal to 1 second. I hope it is clear. So let's solve further now so that our 1 is equal to, by substitution, 2 times 2x over 3 over 330 minus 2 times x over 3 over 330. This will give us 4x over 3 times 2x over 3 divided by 330. I hope you are following. So if that is the case, we can say that by cross multiplication or cross multiplying, we now have what? 1 times 330 is equal to 4x over 3 minus 2x over 3. Okay? So 330 is equal to 4x minus 2x over 3, your LCM. So cross multiply, so that 330 times 3 is equal to 4x minus 2x. So 330 times 3 will give us what? 990. Okay? So 990 is equal to 2x. Divide through by 2, so that x is equal to 990 by 2. X is equal to 495 meters. I hope this was clear. This gives us our answer for x. Okay? Question 24. A force of 200 Newton acts between two objects at a certain distance apart. The value of the force when the distance is halved is... So solution now. Let's extract our given triune components or datas. Number 1, the initial force F1 is 200 Newton. Then the final force is equal to the final force when the distance is halved. Okay? Is F2. Are we together? And is equal to unknown. So our initial distance is equal to, what is it from here? If you observe your question, our initial distance is R1 and is equal to R. Then our final distance is R2 and is equal to R over 2 because it is halved. Exactly. So from F is equal to GM1 M2 over R squared, we don't need GM1 M2. Okay? So hence F is inversely proportional to the square of the distance. Is that clear? So if we do that, F1 R1 squared is equal to F2 R2 squared. By substitution, 200 times R squared is equal to F2 times R over 2 squared. Okay? So that we have 200 R squared is equal to F2 times R squared over 4. So let's cross multiply now. So if we rearrange by cross multiplying, we have 200 times R squared is equal to F2 R squared over 4. Okay, so that F2 is equal to 4 times 200 times R squared over R squared. So R squared will cancel R squared. 400 times 200 will equal 800 Newton. That gives our final answer to this question. Next question. A charge 50 microcoulomb has an electric field strength of 360 Newton per coulomb at a certain point. The electric field strength due to another charge 120 microcoulomb kept at the same distance apart in the same medium is... So solution. Our Q is 50 microcoulomb and is equal to 50 times 10 raised power minus 6 coulomb. Our E is equal to 360 Newton per coulomb. Is that clear? So, what again is given to us? If you observe, our electric force F will equal QE and is equal to 50 times 10 raised per minus 6 times 360. So that this is equal to 0.018 Newton. Are you here? So electric field strength, which is E, are we here? Due to the 120 microcoulomb will give us 120 times 10 raised per minus 6 coulomb if we are converting the micro there. So E is equal to F over Q and is equal to 0.018 divided by 120 times 10 raised per minus 6 and is equal to 150 Newton per coulomb. That gives us our final answer. Next question. The diagram below shows two capacitors, P and Q, of capacitance 5 microfarad and 10 microfarad. Find the charge or the charges stored in P and Q respectively. So using the diagram, you see that our voltage is given. Our voltage is given to be 20 volt and our two capacitors. Okay? So given triune parameters or datas or components, V is equal to 20 volt. Q1 and Q2 are unknown, which is Q of P and Q of Q, unknown. Then our C of P is given to be 5 microfarad. So C of Q is equal to 10 microfarad. So from C is equal to Q over V, our Q will become CV. So Q of P is equal to CPV, as equal to 5 microfarad times 20, as equal to 5 times 10 raised per minus 6 times 20, as equal to 100 times 10 raised per minus 6 coulomb, as equal to 100 microcoulomb. Then Q of Q is equal to C of QV and is equal to 10 microfarad times 20 and is equal to 10 times 10 raised per minus 6 times 20 is equal to 200 times 10 raised per minus 6 coulomb and is equal to 200 microcoulomb. So this gives us our Q of P and our Q of Q. Next question. A wire of length 15 centimeters made of a material of resistivity 1.8 times 10 raised per minus 6 ohm meter has a resistance of 0.27 ohms. Determine the area of the wire. So the given triune parameters, the length is 15 centimeters. Okay? Then, this is 15 meters rather. 15 meters from the question. So we have our resistivity, which is equal to 1.8 times 10 raised per minus 6 ohm meters. Then the resistance is equal to 0.27 ohms. So our area A is unknown, exactly. So recall that resistivity is equal to RA over L. We are looking for A. So A is equal to resistivity multiplied by length over resistance. So A is equal to 1.8 times 10 raised per minus 6 times 15 over 0.27. So that 2.7 times 10 raised per minus 5 over 0.27. Our area is equal to 1.0 times 10 raised per minus 4 meters squared. This gives us our final answer. Next question. A charge of 1 coulomb liberates 0.0033 grams of copper in an electrolytic process. How long will it take a current of 2 ampere to liberate 1.98 grams of copper in such a process? So the given triune parameters, if you look at it, number one, our Z is equal to 0.0033 grams per coulomb. Then our I is given to be 2 ampere. Our M is equal to 1.98 grams. Okay, so from M, let's use this from M is equal to ZIT. We'll now say that T is equal to M over ZI. So 1.98 divided by 0.0033 times 2 will equal 300 seconds. Okay, if our answer is in minutes, 300 divided by 60 will give you 5 minutes. So that gives us our final answer. Next question. The current through a resistor in an AC circuit is given as 2 sine omega t. Determine the DC equivalent of the current. Solution. Pay attention to this question, very important. Please, the data from here given to us as equation. Our y is equal to 2 sine omega t. So I is equal to 2 sine omega t. If you are conversant with waves, exactly, wave equation. Now, A, which is our amplitude, is the same thing as peak current, which is I naught, is equal to 2 ampere from the equation. 2 sine omega t, the 2 is the amplitude, and is equal to I naught. So the direct current, which is DC equivalent, anytime you are solving any problem under this of AC, is the same thing as I root mean squared value. Are you here? So I root mean square value is equal to I naught over root 2. So that you have 2 over root 2. And your law, based on short form, you rationalize. You multiply both the numerator and the denominator by root 2. So I root mean squared is equal to 2 over root 2 times root 2 over root 2. So that you have 2 root 2 over root 4. And then we'll have 2 over 2 times root 2. So 2 cancels out 2. I root mean square is equal to root 2. That gives us our final answer. The last question under this episode, question 30, we have the power dissipated in an AC circuit with an RMS current of 5 ampere, RMS voltage of 10 volt, and a phase angle of 60 degrees is. So given triune parameters from this question, number 1, we have the power to be unknown. Number 2, our I root mean squared is 5 ampere. Number 3, our V root mean squared is 10 volts. And then our phase angle theta is equal to 60 degrees. So using P is equal to IV cos theta. By substitution, P is equal to 5 times 10 times cos 60. So that P is equal to 50 times cos 60. So that P is equal to 25 watts, 25 watts. So that gives us our final answer. If you were to be in an exam hall, especially JAMB, you know that you wouldn't spend more than 2 minutes on a question. In fact, you are advised to spend only 1 minute on a question if you want to be able to meet up with time. So please, as you endeavor to write your exams, take note of your time, because time is part of your exams. If you follow the steps as I've mentioned earlier, the triune component, check your options first, then read your question, extract your triune components or datas, then look for the appropriate formula to solve and to substitute. If you do this, it will save you some time. If you observe, our questions are basically calculative in nature. Okay? So you wouldn't expect calculations all through your JAMB questions. I hope that is clear. I was able to extract these questions for you to cover at least most of the topics, so that in case any of this comes out, you'll be able to tackle them effectively. Please note that you must not leave any question unanswered. Even if you don't know the answer to that question, please tick the answer that comes to your mind and then submit. Who knows? Some of those questions you might get them correctly. I hope that is clear. We're going to be dropping more tutorial videos on each of the topics in both mathematics and physics. Please subscribe, invite your friends. See you in our next tutorial video. Connect to our social media handles at Physics Bible, the Triune Physics, for latest update. Thanks for joining us. Stay equipped, stay liquid.